Hello viewers, my name is Mr.Adebanjo and I want to sincerely welcome you to this video. And this video is as a result of the promise I made in the previous video that we are going to give you this video on Neco 2022 for the mathematics theory. We are going to be solving Neco 2022 for the mathematics theory. In a previous video, you have solved the objective, and if you have not watched it, you may check the channel, and you will see the video we made on where we solved the objective question on Neco 2022 for the mathematics. So, like I said, we are going to be solving the theory part in this video, and we are going to be telling you the topic where they pick each of the question, and also we are going to be solving each question systematically together, one after the other. We are going to be providing solution to them one after the other. So before we get it started, please, if you have not subscribed to this channel, please click on the subscribe button right now, and you can also give a thumb up or like to the video, and also you can also click on the notification button so that you will be notified whenever we post video on this platform. And as you do so, may the good Lord bless you. So like I said, we are solving Neco 2022 for the mathematics theory in this video. So let's get it started. The first question is what you are seeing on the screen right now, and the question number one has A and B part. Question number 1A is on logarithm, so we have to simplify this logarithm. And the second question is on binary operation. So let's start with the 1A. The question says that we are having log 3 over 5 base b plus 2 log 5 over 4 base b minus log 3 over 4 base b. Also, we have to simplify this mathematical expression. Now, how do we do that? The only way we can do this is by using the laws of logarithm. So how do we use the laws of logarithm? You know that we have different quite number of them, so but we are going to use the one that is applicable to the question given to us. So here we are having 2 log 5 over 4 base b. We know that according to the law, these two can go to the power of this 5 over 4, and that's what we do first, and that gives us a log 3 over 5 base b plus log 5 over 4 squared base b minus log 3 over 4 base b. So 5 over 4 squared will give us 25 over 16. Then from there now we can now apply the law of logarithm here also. And we know that addition will change to multiplication and minus will change to division. So that means you have log 3 over 5 times 25 over 16 divided by 3 over 4 base b. And we can change this division to times. So that will be 4 go up, 3 go comes down. From there we have this. Then we can now cut or simplify. 4 can go in 16, that will be 4 times. 5 can go in 25, that will be 5 times. 3 can cancel 3 here. So that means we are left with 5 over 4. So therefore, we'll be having log 5 over 4 base b. And there's nothing we can do further in this kind of question. So we have to simplify. So we have been able to simplify to the simplest form. Question number 1b is on the binary operation. We are given that the operation asterisk on the set Q of rational number is defined by A asterisk B equals to A squared plus B minus 3AB over 4 for all A comma B belongs to the rational number. You have to evaluate 3 asterisk 2, then onward 3 asterisk 5 over 4. You have been given the rule to use A asterisk B equals to this. So anytime we have an expression in form of this A asterisk B, then we can rewrite it in form of this as well. So the first one is 3 asterisk 2. So that means our A will be 3, our B will be 2. So if we put it in this what's it called, rule, we have this. So 3 asterisk 2 equals to 3 squared plus 2 minus 3 times 3 times 2 over 4. So 3 square is 9 plus 2. 3 times 3 is 9 times 2. You give us 18. So 9 plus 2 will give us 11. 11 minus 18 will give us minus 7 over 4. So when you simplify 3 asterisk 2, it gives us minus 7 over 4 when you put it in this into this rule. Also, if we got 2 there, we have 1 over 3 asterisk 5 over 4. Also, you put that here, a will be 1 over 3 and your b will be 5 over 4. So that should give us a 1 over 3 square plus 5 over 4 minus 3 multiplied by 1 over 3 multiplied by 5 over 4, everything over 4. Then 1 over 3 square is 1 over 9 plus 5 over 4. 3 can take care of 3 here. Then you'll be having minus 5 over 4 left there. Then 5 over 4 minus 5 over 4 will give us 0. So we are left with 1 over 9 divided by 4. Then it can also be written as 1 over 9 times 1 over 4. And that will give us 1 over 36. So that's the solution to that question number 1b on a binary operation. Let's go to the next question. The next question is what you are seeing on the screen right now. And the first one is saying that find the sum of the first 7 terms of the progression 4, 8, 16. So this question is from sequence and series. So, but we don't know which one it belongs to, whether AP or GP. We don't know yet until we check this progression given to us, this sequence given to us. We are given 4, 8, 16. You can see that this sequence does not have a common difference. If it has a common difference, we'll say that it belongs to AP, but rather it has a constant ratio. 4 divided by 8 divided by 4 will give us 2. 16 divided by 8 will give us 2 as well. So it has a common constant ratio. So that means it belongs to geometric progression. So in that case, you have to sum 7 terms of this GP. But we know that when it comes to summing geometrical progression together, we have 3 formulas for summing it. There's sum to infinity. There's sum when the common ratio, constant ratio is greater than 1, and there's sum when the constant ratio is less than 1. So in this case, our ratio is greater than 1 because we have r to be equal to 2 here. So that means we are going to use this formula to sum 7 terms together. So we have sum of term equals to a into r raised to power n minus 1 over r minus 1. So we are summing 7 terms together, and our first term is 4 into constant ratio is 2 raised to power 7 because we are summing 7 terms together minus 1 over 2 minus 1. So 2 raised to power 7 is 128 minus 1. So 128 minus 1 will give us 127 multiplied by 4. That will give us 508. So sum of the 7 terms is 508. Then question number 2b is on sequence is on set. Then we are given that x and y are subsets of the universal set U, each of which is defined as follows. The universal set has all numbers divisible by 3 between 1 and 30 inclusive. Then set x has 9, 12, and 24 as the element in it. Set y has 3, 6, 9, and 15 as the element in it. You have to find the value of s complement intersection y. So in this case, the first thing we'll do is to first of all know the element in the universal set as it has been defined. All numbers divisible by 3 between 1 and 30. So the first element there should be 3. Number that are divisible by 3 between 1 and 30. So the first one is 3, next one is 6, 9, 12, 15, 18, 21, 24, 27, then 30, because we are told that 30 inclusive. So then the set x is this and set y is given. So what do we need to find? The first is to find the s complement first. What is s complement? Those are the elements in the universal set that is not in set x. That will be the complement of set x. Those elements in the universal set that is not in set x is the complement of set x. And what are the elements? You have 3, 6, 15, 18, 21, 27, 30. They are not in this set X, but they are here. So now that we know that our S complement, you can find S complement intersection Y. So that will be elements, those elements that is common to set Y and set S complement. And what are the elements? 3 is common, 6 is common, then 15 is common. So therefore, S complement intersection Y will give us 3, 6, and 15. So that's the solution to the question number 2 also. Question number 3 right now is on matrices. Question number 3 is on matrices. We have to sum these 3 equations using Cramer's rule. So we have to solve these 3 equations using Cramer's rule. And we know very well that when it comes to solving simultaneous linear equation using matrices, you have 2 methods. There is a Cramer's rule, which is also called determinant method, and there is a inverse method, which is also called the matrix method. But in this case, you have been told the method to use, which is Cramer, and Cramer's rule is also called the determinant method. So having said that, we can, all you need to do is to remove the coefficient of each variable here so that it can form a matrix for us. So if you remove the coefficient of each variable, you have this, and multiply by the variable, which is give us a column matrix is equal to this column matrix. I hope you understand this, because if you use this one to multiply, if you use this column matrix to multiply this 3 by 3 matrix, it's going to give us this equation back. Now, having done that, the next thing is to do is to find the change. We have to find change, and change is talking about the determinant of this 3 by 3 matrix. So you find the change by finding the determinant of this 3 by 3 matrix. And how do we do that? So we are going to be using this first row to multiply the whatever we get by reducing this 3 by 3 matrix to 2 by 2 matrix. And don't forget that this first row has positional sign. This is positive, this is negative, this is positive. So you are going to be using that. So what do you write? You have 2, which is this 2 here. Then reduce this 3 by 3 matrix to 2 by 2 matrix. So you close the first row, you close the first column. What do you have left? Minus 2, 2, 4, and 2. And that's what you're having here. So you have been able to reduce it to 2 by 2 matrix, but like that. The next one is this positional sign of this 2 here is minus 2. That's why you're having minus 2 here. Then you reduce this matrix to 2 by 2 matrix as well by closing the first row and the second column that this element is. So that means you have 2, then this 2, 3, then 4, 2 left. So this is what you have left when you reduce it. Then the last one is that the positional sign of this one is positive. So you're having plus 2 here. Then you close the first row, you close the third column. You have 2 minus 2, 3, 4 left. And that's what you're having here. Then having done that, you solve this 2 by 2. If solve this 2 by 2 matrix, you find the determinant of it, and this as well, and this as well. How do we do that? By cross multiplying with the positional sign of the first row. Positional sign of the first row is plus, then minus. So then you cross multiply. So that means you'll be having 2 multiplied by minus 2. That will give us minus 4. Then the positional sign of this one is minus. So you're having minus 2 times 4. That will give us minus 8. Then minus 2 into 2 times 2 will give us 4. Then 3 times minus 2 here will give us minus 6, plus 2. 2 times 4 will give us 8. Then the positional sign of this one is minus. So minus times minus will give us plus. Times 3 will give us 6. From there, you can simplify further. Minus 4 minus 8 will give us minus 12. Times 2 will give us minus 24. 4 minus 6 is minus 2. Times minus 2, that gives us plus 4. 8 plus 6 will give us 14. Times 2 will give us 28. So if you add simplify that further, that will give us 8. So the change is 8. Then having known the change, you are going to find the change in x as well. You are going to find change in x. How do you find change in x? Is by using this column matrix to replace the column of x here. So that means you'll be having this matrix now. Then you now find the determinant of it by doing what you have done here also. So if you do that, what you have done there, you will get change in x to be 24. So also you now find change in y as well by using this column matrix to replace this column of y as well. That means you'll be left with this 3 by 3 matrix as well, which you now find the determinant of, and you'll be having 8 as your answer if you do that correctly. Also, you are to find the change in Z as well. You use this column matrix to replace the column of Z. So you'll be having this 3 by 3 matrix as well, which you need to find the determinant of it. Then if you do that correctly, you'll be having -8. Then don't forget our aim is to find X, Y, and Z. So if that should be the case, now what will be our X? X will be change in X over X change. So what's our change in X? 24, as we have gotten here, divided by change, which is 8. That will give us X to be 3. Then to find Y, you have change in Y over Y. That will give us 8 divided by 8. That will give us 1. To find Z, that will give us -8 over 8, which is change in Z over change. And that will give us -1. So the value of our S is 3, the value of our Y is 1, and the value of our Z is -1. You can check if it's correct by putting the value of your X here, Y here, and Z here, and simplify. I believe you are going to get 6. So that's the solution to question number 3. And question number 4 now is what you are seeing right now on the screen, and it's on the front. It's on coordinate geometry. What is the equation of the line which is perpendicular to the line 4x plus 5y equals to 20 and makes an intercept of 3 units on the horizontal axis? Now, then there's another question under as well. So we have to find the equation of the straight line that is perpendicular to this straight line 4x plus 5y equals to 20. How do we do that? All we need to remember first is the condition for perpendicularity. And the condition for perpendicularity is that the gradient of the two lines, the product of the gradient of the two lines must be equal to -1. So when you multiply the gradient of the two lines together, it should give us -1. So then, if you can find the gradient of this second line given to us, then we can now find the gradient of this new line we are looking for. Then, how do we find the gradient of this one? Is by making y source of the formula. Make y source of formula here, you'll be having 5y equals to this 4x coming to this side, will become -4x plus 20. You can now divide both sides by 5. That will give us 1 over 4 over 5x plus 4. This is wrong. That should be 5 in 20 will give us 4. Please, you can change that. That will be 4. Therefore, the gradient of this straight line will be -4 over 5, which you can call our M1. Then we can now get the gradient of this new line we are looking for, which will be our M2. So we know that the product of their gradient should be -1 because they are perpendicular. If that should be the case now, we have -4 over 5 M2 equals to -1. You can cross multiply, you'll be having -4 M2 equals to -5. Minus can take care of minus, so you have 4 M2 equals to 5. So our M2 will be 5 over 4. So that means the gradient of this line we are looking for is 5 over 4. So we know that the equation we are looking for is the equation of a straight line, and it should have this template. It should look like this template, linear template, which is y equals to ms plus c. Now we know the gradient, which is 5 over 4, so we can put that here into this place. So that will give us a y is equal to 5 over 4 s plus c. We are told that the line intercept make an intercept of 3 units. So that means our c, sorry, will be 3. So our c will be 3. So that means the equation we are looking for will become y is equal to 5 over 4x plus 3. So you can multiply through by 4. That gives us 4y plus 5x equals to 12 as the equation we are looking for. So if that's taken care of, let's look at the next question. If the line y equals to 3x minus 2 meet the vertical axis at M, and the line y minus 7 equals to 0 at N, calculate the coordinate of M and N. So there's a line, this straight line, made the vertical axis at M. So at this point M, since the line made this vertical line as M, so that means S will be equal to 0 at that point, because on the y-axis S is equal to 0, as we know. So if that should be the case, now you can substitute this into this equation here. So that will give us y equals to 3 into 0 minus 2, and that will give us y to be equal to -2. So that means coordinate of M will be 0, -2. And also as well, this line also on the vertical axis at point N, then at that means x also is equal to 0 there. And if you put that into this as well, you'll be having y minus 7 equal to 0. So y will be 7 as well. So coordinate of N is 0, 7. So I believe you understand there what you have done there. Let's go to question number 5. Question number 5 is on vector. It's for on vector. We are given that vector OD is equal to 3a plus b, and vector CD is equal to a plus 2b, where a equals to 2y minus j and the b equals to 3i plus 2j. We have to find vector OC. We can use a triangular law to solve this kind of question. So we can see, you can draw the triangle and label the vertices. So I label it OC. I move from OC to OCD, which seems now moving from O to D. Like if you want to O or this OD, if you want to go from O to D, same thing as going from O to C and going from C to D. Sorry, plus going from C to D rather. So that's what you're having here, that OD is equal to OC plus CD. And our aim is to find OC, so you can make the subject of the formula here. So OC will be OD minus CD. So we will be giving our OD to be 3a plus b, and we will be giving our CD to be a plus 2b. So if you simplify this further by opening the bracket, you'll be having minus a minus 2b here. Then if you now collect like time, you have 2a plus 2a minus a, that give us 2a. You're having 3a minus a rather, that give us 2a. Then b minus 2b will give us minus b. And we will be giving the value of our a and the value of our b here, so you can substitute that as well. You'll be having 2 into 2i minus j, close the bracket, minus open bracket 3i plus 2j. And if you open the bracket, you have 4i minus 2j, then minus 3i minus 2j. So 4i minus 3i will give us I, minus 2j multiply minus 2j minus 2j will give us minus 4j. So that's the vector OC. So I hope you understand that question as well. Now, if you have not subscribed to this channel, please do well to click on the subscribe button right now on the channel, like the video, and click on the notification button so that you'll be notified whenever we post the video on this channel. Now let's move to the next question, please. Next question is on friction, and that's what we are seeing right now on the screen. A body of mass 15 kg rests on a horizontal floor. If the coefficient of the friction is 0.2, we have to determine the minimum force that is required to make the body just move when pulling. A, horizontally. B, at an angle of 60 degrees to the horizontal. We have to take our answer correct to 1 decimal place. So there's a mass of 15 kg on horizontal plane. So of course there should be a force that can help that can move this mass horizontally like that. But what is the we need to get the mass, the weight of this mass, and weight is mass times as gravity. So, and that will give us 15 times 9.8, because we will be giving the g to be 9.8 here. That gives us 147 Newton as the weight of this mass. So if that should be the case now, according to the law, third law of motion, that says that for every action there is equal and opposite reaction. So that means there should be a reaction against this mass that is being done by this horizontal floor. That should be, this horizontal floor should give a opposite reaction to the weight of this mass. So that is R, and they are going to be equal as well. Because if they are not equal, if this weight is greater than the reaction, that means the mass will cave in. But if they are equal, that means the mass will stay on the floor. So that means the R here, this reaction should be equal to the weight of the object. Or so, and we know that friction force is equal in friction force is equals to the coefficient of friction multiplied by the reaction So we are looking for the force that can move it horizontally, which is our F equals to 0.2 times the weight, which is sorry, which is the reaction, which is equal to the weight, and that will be 147. So 0.2 times 147 will give us 29.4 Newton as the horizontal force that can move this object. Also, we are also to look for the force that can move the object when it's on an inclined plane at angle 60 degree, and that was we are having here as the diagram. So when it comes to force on an inclined plane, we know that we can resolve the force using two components, either x component and y component. But we are looking for the force that can pull this object down. That should be horizontal component, and the force along the horizontal component is mg sine theta, where our m is the mg is the weight we have gotten here, sine theta, theta being the inclined angle here. So we have 147 sine 60, and that should give us 127.3 Newton as the solution to that question. Question number 7 is on normal distribution rather. It's on normal distribution. We have ABC company manufactures bulbs that have lifespan which are normally distributed with mean 220 hours and standard deviation of 10 hours. Out of a sample of 5,000 bulbs, how many would you expect to have lifespan between 200 hours and 240 hours? Like I said earlier, the question is from normal distribution. Then we have to standardize this 200 hours and 240 hours as well. And how do we standardize it? It is using Z, which is standardized value equals to the number we want to standardize minus the mean divided by the standard deviation. So we want to standardize 2 hours and 240. So that means our x is 200 and 240. So if that should be the case now, our x1 is 200, so we put it here. We have 200 minus 220 over 10. So that will give us the standard value of x. That will give us minus 2. For 240 as well, we also put it our x here, which is 240 minus 220 as the mean over the standard deviation, which is 10. So that will be 2 as well. So that means the standard value of 240 is 2. Then that we can put in probability, because normal distribution is talking about probability. Whether if you want to use Poisson rules and binomial distribution or normal distribution. But because it's on normal distribution, so we are still looking for probability as well. So if that should be the case, that means you have standardized these two values now. So we having probability of a standardized value of minus 2 less than or equals to standardized value less than or equals to 2. Then to now do this, all you need to do is to represent these standardized values on this graph, which is this bell-shaped graph. This bell-shaped graph, you have minus 2 on the minus 2 axis, and this is the middle, this is the positive 2. So we are looking for the area under this in this bell-shaped diagram. Then how do we do that? This minus 2 is just telling us the direction where it's going to this it's going to be in negative side of this, and this one is in positive side. So to find the area here, that will be area of this plus the area of this from here to here plus from here to here, that we are doing now. And that's what this represent, all this story you have here, that what it represents. So but how do we find the standardized values of minus 2? That you can get from your normal distribution table. I didn't provide it for this video, but you can check your 4-figure table to or the back of your textbook. You will see the normal distribution table where you can check the standard values of any number. So you're going to set the standardized value of 2 and 2 here. Forget about this minus here. You got to just telling us where you're going to put this value. So if it is positive, you are going to be there here. If it's negative, they will be at this side. But one is more negative, one is positive. So we have here, we have here. So we are going to find the standard values of 2, and that you will get as 0.4772 if you check your table. And also for this, you also have 0.4772, and if you add it together, you have 0.9544. So the how many so we'll be having 0.944 probability of expected lifespan between 200 hours and 240 hours. But we also say that we should find it out of, we are using sample of 500 bulbs. So how many will have this lifespan? So what you do is that whatever you get here, you multiply by this number of samples given to you, which is 500, and that will give us 4772.2 bulbs to have the lifespan of between 200 hours and 240 hours. I hope you understand that question number 7 very well. So, of course, if you may not understand, you may check your normal distribution topic. It's very simple as well. Let's go to the next question, please. The next question is what you are seeing right now on the screen right now, and the question is on the matrix as well. We are given this matrix A, which is 3 by 3 matrix. We have to find the determinant of the matrix. We have to find the adjoint of the matrix. We have to find the inverse of the matrix. Then later use the matrix to solve this simultaneous equation. And this is another question. So let's get it started. Question number 9a. We have to find the determinant. 9a, Roman figure 1. We have to find the determinant of this matrix, which is what you have done in the past. If you look at question number 3, I think it's on we have to use determinant Cramer's rule to solve the simultaneous equation, which we use determinant method. So if that should be the case, now how do we find the determinant of this 3 by 3 matrix? In this case, I've jumped some steps, so I believe you should be able to understand what I've done here. We use the element of this first row and their positional sign. Then we now reduce this 3 by 3 matrix to 2 by 2 matrix one after the other. So the first one is plus, you have plus 2 here. We do this to reduce this 3 by 3 matrix to 2 by 2. Close this row, close this first column. You have 0, minus 1, 1, 1. Then cross multiply with the positional sign of this first row. So you'll be having 1 times 0 will give us 0. Then this minus times minus will give us plus here. Then 1 times 1 will give us plus 1. I hope you understand what I've done there. Then the next one is the positional sign of this 3 is minus 3. You put it there. Then reduce this 3 by 3 matrix to 2 by 2. Close this first row, close this first column. Sorry, close the first row, close the second column. You have 1 minus 1, 1, then 1 left. Then cross multiply. 1 times 1 will give us 1. Then this minus also will change to plus. So I hope you understand that. Then 1 times 1 will also give us plus 1. Then the last row, sorry, the last this 2 here also, we have plus 2. Then close this first row, third column. We have 1, 0, 1, 1, 1 left. Cross multiply. 1 times 1 will give us 1. Then minus 0. Then if you simplify that further, 0 plus 1 is 1 times 2 give us 2. 1 plus 1 is 2 times minus 3 give minus 6. 1 minus 0 is 1 times 2 give us plus 2. If you simplify that further, I think that should give us a minus 2 as our answer. So our determinant of A is a minus 2. Question asks us to find the adjoint of matrix A. What is adjoint of matrix A? Adjoint of matrix A is the cofactor of cofactor transpose of this matrix. We have to find the cofactors, which is represented by C, and we have now to transpose the matrix, whatever we got. How do we find the cofactor of matrix A? Then you have to find the cofactor of each element in this 3 by 3 matrix. Each element has a cofactor. How do we find a cofactor? Is by reducing this 3 by 3 matrix to 2 by 2 matrix for each element in this 3 by 3 matrix and using their positional sign. Don't forget that the positional sign of these two is plus, minus, plus, minus, plus, minus, plus, minus, plus. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Those are the positional sign of this 3 by 3 matrix, and we are going to use their positional sign to reduce them to 2 by 2 matrix one after the other, and that's what we have done here to get the cofactor. For the element here, which is element in the first row, first column, we have A11. So if you reduce it to 2 by 2 matrix, close here, and don't forget that the positional sign of this one is plus. So you have plus here. I did not write it, but if you close it, you have 0 minus 1, then 1. Then find the terminal of this 2 by 2 matrix. You have a 0 plus 1, that gives us 1. Then A12, that's the element in the first row, second column, which is this 3. But we are not going to write the 3 in front because we are not doing it like this. We are going to forget about don't put the 3, but put the sign. The sign is minus. Then reduce it to 2 by 2 matrix. Close the first row, close the second column. You have a 1, minus 1, 1, and 1 left. Then find the terminal of this 2 by 2 matrix. 1 times 1 will give us 1. This minus will change to plus because the positional sign of this one is minus as well. So we have 1 times 1 give us plus 1. And 1 plus 1 is 2 times minus, that gives us minus 2 also. Then A13, that will be element in the first row, third column, which is this 2. And the positional sign of this one is plus. So then reduce it to 2 by 2 matrix. That we have 1, 0, 1, 1, which is this as well. And solve this 2 by 2 matrix, we have 1 minus 0, and that gives us 1. A12, element in the second row, first column. This is the element in the first row, second row. This is the second row, and this is the first column, which is 1 here. So close this second row, first column. We have 3, 2, 1, 1 left. 3, 2, 1, 1. And the positional sign of this 1 here is minus. So that's why you have minus here. So then solve this 2 by 2 matrix. You have this. I hope you understand that. Then A22, that will be element in the second row, second column, which is this 0 here. So, but the sign of this 0 here is a plus. So then reduce this to 2 by 2 matrix. Close the second row, second column. You have 2, 2, 1, 1 left. So we have here. Then solve this 2 by 2 matrix. You have 0. Then A23, that will be element in the second row, third column, which is this minus 1. And the positional sign of this minus 1 is a minus as well. Then reduce it to 2 by 2 matrix. Close this, close this. You have 2, 3, 1, 1, which is this. Then solve this 2 by 2 matrix. You have this. Also, the element A31 is the elements in the third row, first column, which is this 1. Then this positional sign of that one is also plus. Then close the third row, first column. We have 3 to 0 minus 1 left, which is this. Then solve this 3 by 3 matrix. You will have this answer, minus 3. Then A32, that will be elements in the third row, second column. That will be this 1 here. Then the sign of that one is, the positional sign is minus. Then close the third row, second column. You have 2, 2, 1, minus 1 left, which is what you have in this 2 by 2 matrix. Then solve it, you have 4 as your answer. Then 3 by 3, 3, A33 is element in third row, third column, which is this 1 here. Close it, you have 2, 3, 1, 0 left, and the positional sign of this 1 here is a plus. Then solve this 2 by 2 matrix, you have minus 3. Then you now rewrite the answer in this. You have 1, you have minus 2, we have 1 here, minus 1, 0, 1, you have minus 3, you have 4, and we have minus 3. So this is the cofactor of this 3 by 3 matrix. Then don't forget that adjoint says that cofactor transpose. So when you get this cofactor, then you transpose it. Then that will give us the adjoint. Then how do we transpose a matrix? That means the column become row and the row become column. So this column can become row. That means I have 1 minus 1, then minus 3. Then this column also become row, minus 2, 0, and 4. Then this column also become row, 1, 1, minus 3. So that is the adjoint of that matrix A. Then to find the matrix of inverse of the matrix A, inverse of matrix is the adjoint of that matrix divided by the determinant. And you have already gotten the adjoint, you have already gotten the determinant. The determinant is minus 2, and this is the adjoint of the matrix. So that means we'll be having this matrix divided by minus 2, which it can be written as a minus 1 over 2 into this matrix. So that will give us the determinant of that matrix A. So I hope you understand what you have done there. Then let's go to 9b. We have to use this the inverse we have gotten here in 9a above. Solve the following simultaneous equation. So you have to use this inverse we have gotten. the inverse of this matrix, which is this answer here, to solve this simultaneous equation. How is that possible? If you remove the coefficient of these variables here, you'll be having this matrix back. You'll be having this matrix back. 2, you have 3, you have 2. Then x is 1. There's no y. So that means equation of y there is 0. Then minus 1 is for z. You have 1, you have 1, you have 1. So you can see that this matrix, this equation you have here has this matrix. When you remove the equation of the each variable, you have this matrix. So that's why it is possible for us to use this inverse of this here on 1 to solve this. And since we have gotten the inverse already, so what? Let's see how to use the inverse we have gotten to solve this question number 9b, and that one is in the next slide, and that is it here. So when you remove the coefficient of the variables, you have this multiplied by the variable equals to this column matrix. Let me take you to primary school or primary school. When you have AB is equals to C, I want to make B sort of formula. What do? I think we will divide both sides by A. Am I correct? If that should be the case, you have B is equals to C over A. That's what you're supposed to be right to have. B is equal to C over A. But don't forget that you can also rewrite that at A raised to power minus 1 then C, as you are seeing here right now, which A raised to power minus 1 means 1 over A C. And I hope you understand what we have gotten here. So this A raised to power minus 1 is talking about the inverse of A. So fine, if you understand that now, what you are having here is same thing as the expression you are having here as well. This one stands for A, this one stands for B, this one stands for C. So I want to find the value of x, this column matrix S, Y, Z. I want to find the value of it. So that means I can divide both sides by this 3 by 3 matrix. When I divide both sides by 3 matrix, this by 3, divide both sides by 3 by 3 matrix, then I'll be having S, Y, Z equals to the inverse of this 3 by 3 matrix multiplied by this column matrix, which is what you have gotten here as an example. I hope you understand what I've done here. So this one is talking about we have to find the inverse of this 3 by 3 matrix, which is what you have already gotten here. Which is what you have already gotten here. I hope you understand that. So you can lift this, which is what you have to do. You have to use the inverse of this to solve this question. So you can lift the answer of this one. When you lift it, you bring it here. That way you have done. That way you have it here. So the inverse of this matrix is this. Then multiply by this column matrix. Then as using the understanding of matrix, this is a scalar. You can multiply the elements in this 3 by 3 matrix, and that's what we have done. Minus half multiplied by 1 will give us minus half. Minus half times minus 1 will give us 1. 1 times 1 will give us a minus, will give us half. Then minus half multiplied by minus 3 will give us 3 over 2. Then this multiplied by minus 2 will give us 1. Times 0 will give us 0. Times 4 will give us minus 2. Times 1 will give us a minus half, times 1 give us minus half, times minus 3 give us a 3 over 2. Then multiply by this column matrix. Then we know that this 3 by 3 matrix can multiply this column matrix according to the condition for multiplication of matrices. So this row will multiply the column, row multiply column, row multiply by column. And that's what you have here. Minus half times 1 will give us minus half. Then plus half times minus 1 will give us a minus half, plus 3 over 2 times 2 here will give us 3. That will give us this. Then this second row also will go multiply this column, we have this. This third row also will go multiply this column, we have this as well. Then this we must simplify further. You will be having minus half, that will give us minus 1 plus 3, that will give us 2. 1 plus 0 minus 4 will give us minus 3. Then minus half plus half will give us 0 plus 3 will give us 3. So that means the value of our x is 2, value of our y is minus 3, the value of our z is 3. So that's the solution to this question. And you can confirm as well by putting your 2 here, that will give us 4. Put your minus 3 here, that will give us minus 9. 4 minus 9 give us minus 5. Then put your 3 here, give us 6. Minus 5 plus 6 will give us 1. So that shows that it is correct. So let's go back to the question. We have to solve this question number 9c. y-axis intersects with this line joining the point 3 comma minus 2 and the point minus 9 over 2 and 8, such that it divides the line internally in certain ratio. Find the ratio and the coordinate of the point of intersection. The question is on the coordinate geometry, that is internal and external ratio. So now how do we do that? Let's go back. Then we are not given the ratio. We have to find the ratio and the coordinate of the coordinate of the intersection, rather coordinate of the intercept. So let's go back again. The coordinate of the intercept. Okay, let's say we don't know the ratio. You can say let the ratio of the interception be m ratio n, m to n rather. Then the coordinate is x comma y. But how do we find the coordinate of the intersection of a line in using the internal and external ratio? That will give us mx ms2 plus nx1 over mn, where x2 and x1 can be gotten from the coordinates given to us of the line. Also, our y also can be gotten as a my2 plus ny1 over m plus n, where m and n is the ratio of the where it divided, and this s and y here are the coordinate of where the y-axis intercept the line. Then also, how do we do that now? We know the value of our s2. Let's go back. S2 is minus 9 over 2, and S1 is 3, Y2 is 8, and Y1 is minus 2. So if you put that here, you will be having, this our S2 minus 9 times M will give us minus 9 over 2M plus S1 is 3, you have 3N over M plus N, comma Y is equals to Y2 is 8, and our Y1 is minus 2 over this. So we don't know the ratio of the internal, where it divide the line internally. So we can call it, let's assume the ratio is a k ratio 1. So if the ratio is k ratio 1, and we are told that the y-axis intercept the line, the y-axis intercept the line, that means at that point where the y-axis intercept the line, s is equal to 0. So that means the value of our x here is 0. So that means this one become 0 is equals to minus 9 over 2, and our m is k, and our n is what, 1. So plus 3 times n, which is 1 over k plus 1. Our k is m. So according to what you have said here, that we should assume that our m is 1 k, and our n is 1. So if you if you simplify that further, you'll be having 0 is equals to minus 9 over 2k plus 3 over k plus 1. Then from there we can cross multiply. If k plus 1 multiplies 0 here, that gives us 0. So you're having minus 9 over 2k plus 3 equals 0 left. Then collect like time, that will give us minus 9 over 2k equals to minus 3. Minus we take care of minus, k will be 6 over 9, the same thing as 2 over 3. So that means the ratio of the internal will be 2 over 3 to 1. That's the ratio of this, of the internal. So 2 over 3 to 1. Then having known that, then we can now find we have gotten the ratio, but the question also find the coordinate of the point where the y-axis intercept the line. So, and that is x and a y. So we already know the value of our x to be 0. So we need to get the value of y. Now that we know the value of our m and n, we can find the value of our y here. So all you need to do is to substitute the value of your m and n here. So from y is equals to 8m minus 2n over m plus n is equals to, we have 8 into, what's our m? 2 over 3 minus 2 into 1 over 2 over 3 plus 1. Then that should give us, if you simplify that further, that will give us 16 over 3 minus 2, then minus 2 over 5 over 3. Simplify that further, that will give us 16 if you find the LCM of this one, 16 minus 6 over 3 divided by 5 over 3, then change this one to time, that will give us 10 over 3 times 0 over 5, and that will give us 2. Then the coordinate of the line point where the y axis intersect the x the line is 0, 2. So that's the solution to that question number 9C as well. I hope you understand what you have done there very well. Question number 10 is what you are seeing right now on the screen, and it's on from functions. Question number 10 is from function. If f and g are mapping defined over a set of real number by f of x equals to x plus 2 and g of x is equals to x squared plus 1, we have to find the value for x for which f of g is equals to 4 and g of f inverse of 2 as well. Then how do we do that? It's very simple as well. The first one, we have to find the value of x for which f of g is equal to 4. Now we have f of x to be x plus 2, g of x to be x squared plus 1. So how do you find f of g? Is by putting the value of g into x. This is composite function. Composite function, you have to put g of x into f of x. So anywhere you see x in f of x, put g of x. So that means the s squared plus 1 will replace this x here. That means you have s squared plus 1 plus 2. Then you can simplify that further. That will give us s squared plus 3. So that's our g of x. So that's our f of g rather. Then, and whatever you get here, you have to equate it to 4. So that means you have equals to 4. From there, you can collect later. You have s squared equals to 4 minus 1 minus 3. That gives us 1. You can take the square root of both sides. That will give us plus or minus 1 as the value of our x. Then also g of f inverse of 2. So also this is composite function as well. But you first need to get the value of your f inverse of x as well. Before you now find f inverse of 2, before you now put that into g of x. Let's go there as well. So like I said, you first need to find the inverse of x. So how do you find the inverse of f of x? So you know that f of x is same thing as y is equals to x plus 2. Then you can make this x of the formula here. That will give us s to be equals to y minus 2. So that means f inverse of s will be equals to this y will change to x minus 2. So now that we know the f inverse of x which will be s minus 2, we can find f inverse of 2. So that means f inverse of 2 will be 2 minus 2. That will give us 0. So that means g of inverse of f of inverse of 2 will be whatever you go to your g of x. G of s is s squared plus 1. So put everything here into g of x. So everything you got in f inverse of 2 is 0. Put it in g of x. So and our g of x is saying that we have s squared plus 1. So wherever you see s, you put 0 there. That will be 0 squared plus 1. Then 0 squared is 0 plus 1 will give us 1. So that's the g of f inverse of 2. Then if that is the case, we have to find also we have to find for the 10b, we have to find the value of k for which s squared minus ks plus 10 a perfect square. This is a quadratic expression. We have to make it a perfect square. And how do we do that? We know that when it comes to making a quadratic expression a perfect square, we can use the discriminant. Discriminant is what defines the nature of a quadratic expression or quadratic equation. So when the discriminant is equal to 0, that means it's a perfect square. And what is discriminant? B squared minus 4ac is equal to 0. So our b is a minus k, our a is a 1, and our c is a 100. If we substitute that, we have a minus k squared minus 4 into 1 into 100 equals 0. If we multiply this out, it gives us minus 400 minus k square will give us a k square. Collect like time, k square equals to 400. Then value of k will be plus or minus 20. So I hope you understand question number 10 very well. Let's go to the next question. Next question is also on coordinate geometry. Show that the points S, Y, and Z are collinear. So that's the first question. When do we know that 3 points are collinear? When the gradient of these two of them is equal to the gradient of the other two. So gradient of SY should give us the gradient of YZ as well. That is when they are collinear. And that's what we have here, that the 3 points are collinear if gradient of SY is equal to gradient of YZ. So, and how do we find gradient of 2 points when given their coordinates? That should be y2 minus y1 over s2 minus x1. So between x and y, you have 6 minus 2 over 4 minus 1 equals to 4 over 3. And between y and z, we have it to be 14 minus 6 over 10 minus 4. And that should give us 8 over 6. And that will give us a 4 over 3. And we can see that they have the same gradients. So that means the 3 points are what? Collinear. Question number 11b. Calculate the area of a quadrilateral whose vertices are P, Q, R, and S. You are given the vertices of a quadrilateral, and to find the area of that quadrilateral. Then that should give us the area of a quadrilateral given the coordinate of the vertices to be half into open bracket s1 y2 minus s2 y1 plus open bracket s2 y3 minus s3 y2 close the bracket plus s3 y4 minus s4 y3 plus open bracket s4 y1 minus s1 y4, then close the bracket and the main bracket. How do we get our all these points we have here from the coordinates? From the first coordinates, you have x1 and y1. Second coordinate y s2 y2 y3 s3 y3 s4 y4, and also that's what we define here. Then all you need to do is to substitute the values you have gotten here, and when you substitute it correctly, you have this. And when you have this, then you can simplify. That will give us 2 here, and this one will give us plus 3. This one will give us plus 2. This one will give us plus 8. Then this one will give us plus 32, and this one will give us plus 12. This one will give us 18, and this one will give us plus 8. And if you simplify that further, we have 5 plus 10 plus 44 plus 26, and that will give us half of 85, and that will give us 42.5 square units as the area of this quadrilateral. I hope you understand that. Now let's go to the next question. The next question is on force. You have to find the resultant force of resultant force acting resultant force of forces acting on a point, and the point is at equilibrium. So we have like 5 forces here now, and we are given their coordinate, their magnitude, but we don't know the magnitude of 2 of the forces, P and Q. So we have to use this to find the value of P and Q, and that's what we are doing here right now. And how do we do that? Is by drawing the diagram of the forces acting on at a point. So, and this represents the diagram of these 5 forces. We have forces 5 having an angle of 60 degrees, forces 8 having 45 degrees, P 300, and 12 Newton having 120 degrees, and 80 having 240. Then if that should be the case, we can rearrange these forces based on the magnitude of their angles. 45 will come before 60. That should be for 8. So if you draw your S and Y axis, then 45 will come before 60. So you draw the this force is 8 Newton. Then from here to here should be 45. From this line to this XI is 45. So of course this is 45, 45 as well. So you are minding from this force to this S axis. I hope you understand that now. Good. Then also the next one is 60 degrees for 5 Newton. Draw the force. Then from here to here is 60. That means from here to here will be 30. So don't forget that we are minding the angle between the line and the x-axis. So from here to here should be what, 30. Then if that should be the case, the next one is for P, sorry, for 12. That is 120 degrees, and 120 will fall in this second quadrant. So if from here to here is 90, and from here to here is 120, then that means from here to here should be 30. So because we need the angle from here to this x-axis, so that should be 30. So 90 from here to here is 90. 90 minus 120 will give us 30 from here. I hope you understand that. Also for the next one, which is 240 for Q, 240 will fall in this quadrant. Then if that should be the case now, we know that from here to here is 240, and we know that from here to here is 270. From this north to this Q, this force Q Newton is 240 as you have been given, but we know that from this north to this west is 270. So if we remove 240 from 270, that gives us 30 degrees from this s-axis to this force. Then the last one is 300 degree, which is for Q for P. So 300 should fall in this the fourth quadrant. Then also, if from here to here is 300, that means from here to here is 60. So if that should be the case as well, we can also we have this one to be 60 as well. Then if this one is 60, that means this from here to here is also 30, but you can use the 60 as well. All you need to do is to know what you are doing. Then we can now resolve all these vector based on their component. We have x component and the y component. So let's resolve this the vector this force 8 Newton based on x-axis and the y-axis component. So for the vector for the force 8 Newton, if you resolve the vector on the force along the x component, we have 8 cos 45 degrees, and that will give us 5.66 Newton. And if you resolve it along the y-axis, you have 8 sine 45 degrees. That gives us the same answer, because then if you resolve force what's it called, 5 Newton, this one as well along the x component, that will give us 5 cos 30 degrees 4.33. And if you resolve this one along the y component as well, you'll be having 2.5 as well. Also for the next force, which is 12 Newton, if you resolve it along the x-axis, we have a 12 cos 30 degrees. That gives us 10.4 Newton. And if you resolve it along the y-axis as well, we'll be having along this y-axis here, y is negative at this axis, so we'll be having minus 12 sine 30. That will be minus 6.0. Then if you resolve this force Q Newton, then we'll be having for the x-axis component, you'll be having negative, because at this point of x is negative, so you'll be having s q cos 30, and that will give us 0.660, minus 0.866 q rather. Then if you resolve it along the x y axis, it's also negative at this side, so minus q sine 30 will also give us minus 0.5 q. Then for the last force, which is P, if you resolve that one along the x component, that for this, that will give us a negative, so minus P cos 60 equals minus 0.5 P. Then if you resolve it also along the y component as well, you're having P sine 60 0.66 P. So since we have been told that the point is at equilibrium, so the point is at equilibrium, that means the summation of all the x components should be equal to 0, and the summation of the y component should be also be equal to 0. So that's why you have the summation of S component is equal to 0. So sum all the forces of S component, this plus this one plus this together. When you sum these together, you'll be having 5.66, which is for this, plus 4.33 plus 10.4, which is for this, minus, because this one is having minus 0.866q. Then this one is also having minus 0.5p equals 0. Collect lifetime, you sum these three together, you have a 0.88. Sorry, if you sum these three together, you'll be having 20.35. So then 3 to the other side, you'll be having minus 0.66q minus 0.5p equals to minus 20.39. So you can multiply through by minus, that means you change to 0.866q plus 0.5p equals to 20.39. You can call that equation 1. Do the same thing for y components. Sum all the y components as well together, you'll be having this as well. So which, if you simplify further, you'll be having 0.5q plus 0.866p is equals to minus 2.16. So you can now solve these two equations simultaneously now using any method you know. If you solve equation 1 and equation 2 simultaneously, I use the elimination method by making this q to be equal in equation 1 and equation 2. You multiply equation 1 by 0.5 and you multiply equation 2 by 0.886. So it will give us what you're having here. Then you can now add together. If you add this one, you add this together, you have this. Add this together, you have this. Then you can find your p from there by dividing both sides by 0.99956. That gives us 8.3 Newton as the value of our p for p. Then you can substitute the value of your p in the end of the equation 1 or 2, and that will give us, and you simplify further, that will give us a q to be 18.74 Newton. So that's the solution for question number 12a. Then question number 12b now is also on a vector. We are given that the positional vector of position of vector A, B, and C are this, and this respectively. You have to find the cross product of vector A, B, and vector B, C. So what you need to do is to find vector A, B. Vector A to B is a addition of A plus B. So we have A to be this and B to be this. If you add it together and collect lifetime, 4i plus 3i will give us 7i, minus 9j plus 4j will give us minus 5j, then minus k plus 5k will give us plus k. Then also vector BC is addition of B to C. So if you add it together, you'll be having 5i plus 2j plus 8k to this. Now we now have this vector AB and vector AC now in the direction of I, J, and K. So we have to find their product using by crossing it. So how do you do that? You can put them in matrices form I, J, K, then the equation of each of the direction. We have 7 here, 7 high, minus 5, we have 4, we have 5, we have 2, we have 8. Then find the determinant of this matrix. You'll be having high into, we do this into 2 by 2 matrix. You have this time this value of minus 40, then minus 8. The positional sign of j is a minus. You have minus j into, close this, you have 7 times 8, that gives us 56. Then this one is positional sign of this one is minus 4 times 5 will give us minus 20 plus k, close this, you have 7 times 2 14. Then the positional sign of this minus 5 is minus, so we have minus times 1 will give us plus, 5 times 5 will give us plus 25. So if you simplify that further, that will give us minus 48 times I will give us minus 48i. 56 minus 20 will give us 36 times minus j will give us minus 36j. Then 14 plus 29 will give us a 39, and that will give us plus 39k. So that's the solution to question number 12 altogether. So before we continue, if you have not subscribed to this channel, please click on the subscribe button right now, like and share the video, and click on the notification button. Next question now is question number 13, and it's on projectile. We are told that a projectile is a particle is projected with an initial speed of 45 meters per second at an angle of elevation of q given by sine inverse of 0.5. Find the greatest height reached by the particle, horizontal range, time of flight, the magnitude and direction of the velocity after 2 seconds, given that g is 9.8 meter per second square. So we have been given the initial velocity, and we have been given that the angle of elevation is minus 0.5. So from there we can find the angle by finding the inverse of minus 0.5, sine inverse of sine inverse of 0.5, and that gives us our 30. Sine inverse of 0.5 is 30 degrees. Then from there, what is the greatest height? The formula of finding greatest height of a in projectile, that should give us a u square sine square theta over 2g. Then from there, you can substitute the value given to us here. You have 45 square sine square 30 over 2 times 9.8. Sine 30 is a half. Square will give us 1 over 4. Multiplied by this will give us a 506.25 divided by 19.6. If you divide it, that should give us a 25.829 meter. So you have to find the range as well. Range is a u square sine 2 theta over g. So substitute that as well into the formula. You have this. Theta is 30, then 2 theta will be 60. So from there, if you simplify that, give us 178.95 meter. You have to find time of flight, which is t small t equals to 2 u sine theta over g. Put your values as you have been given here into you have our t to be 4.95 seconds. Then you have to find the magnitude of its velocity after 2 seconds. So with that, we are looking for the final velocity now, because you have been given the initial velocity. And once you bring out the equation of motion that involve final, initial, you have been given the time, and we know the gravity. So but you are told that the projection is against the gravity. That means this sign will change to minus. So that means that we have a final velocity equals to initial velocity is 45 minus 9.8 times 2 seconds. Then if you do that, you have 45 minus 19.6, and the v will be 25.4 meter per second for the final velocity you have to find. And that's question number 13 also. Now question number 14 now is on correlation and regression. It's on correlation and regression. You have been given that the score of 10 students in 2 tests are shown in the table below. We have students from 1 to 10. You have their test A and test B, giving their scores. So you have to plot this scatter graph. You have to plot B against A and draw the line of regression. So all you need to do is to plot a scatter graph, and based on the information given to us. Now, before you draw the graph, you need to know the line of your best fit. And the line of best fit, I need to you need to know the point where the line of best fit will pass through. Then and where do you get that? The line of best fit, where it's going to pass through, is going to be the coordinate of this x mean, the coordinate of mean of x and the mean of y. So how do we get that? How do we get mean? Sum x together and sum y together. How do you know the y? How do we know the x? Because we are not told in the question. But the question said that we have to plot b against a. So that means our b will be on the y-axis and our a will be on the x-axis. So that means this test A will be on the x-axis. So if you sum it together, you have 54 divided by 10. That gives 5.4. That will be mean of x. Then for y, for the mean of y, that's our test B. So add it together, that gives 55 also. Divided by 10, that gives 5.5. So that means the point where the line of best fit will pass through is 5.4, 5.5. So then you can now plot the graph of this scatter graph now. Let's see that first. So if you plot the graph, you'll be having something like this. These are test B against our test A. And we use the scale of 2 units to represent 2 centimeters to represent 1 unit on both axes. 2 centimeters to represent 1 unit on both axes. So this is 1 to 12 on y-axis, 1 to 10 on the x-axis. From there, we can now plot each of these points given to us. When our b is 9, our b is 9 here. Where's 9? 9 is here. Then our a is 10. Our a is 10 here. So they meet here. This is the first point. When our b is 3, which is here, and our a is 1, our a is 1. Our b is 3, our a is 1. This is b is 3 here, and our a is 1. Pardon me for that. It should be here. We should have a point here. B is 3. Trying to check again. B is 3, A is 1. So they should have a point here. We should have a point here. So next one is B is 10. B is 10. Y is A is 5. A is 5 here. B is 10 here. So a point is here. Also, B is 8. Then A is 9. B is 8. Where's B? B is 8 here. A is 9 here. So they should meet here. Then also 7, 7. This is 7 and this is 7. So a point is here. Also, B is 2. Then B is 2. A is 3. This B is 2 here. A is 3. A is 3 here. B is 2 here. So that means you have a point here. Then also, we have B to be 4. Then A to be 7. B is 4. A is 7. So we have a point here as well. Then B is 6. A is 4. B is 6. A is 4. We have a point here as well. Then we have B to be 1. B is 1 here. Then A is 6. So that means we have a point here. B is 1 here. Then A is 2 rather. So we have a point here, as you can see. Then we have B to be 5 here, and A is 6. So we have a point here. So these are the points when you draw this graph of this scatter graph. Then this is the line of best fit. This is the line of best fit, that straight line, and it passes through these coordinates you have gotten before. This 5.4 and 5.5. So locate the on the x-axis 5.4, which is this point, and on the y-axis 5.5, which is this point. So they meet here. This circle, then you draw your line of best fit. So from there, this is a line of best fit. Then the question asks us to draw the line of draw the scatter graph and draw a line of best fit, which is what we have done here. Then after that, you have to find the equation of the best of the regression. So let's go back. To find the equation of the regression, the equation of the regression is a linear equation, because that straight line is a linear equation. So the model of a regression is a linear equation. Y is equal to ax plus b, where our a is the gradient or slope, and our b is the y-intercept. So we can find the gradient by drawing. Let's go back. Find the gradient by making a right angle triangle with this straight line, and that's what you can see here right now. From here to here, we make a triangle with it. Then find our change in y over change in x to find the slope. Find the change in y over change in x. So if you go back, so our change in y over change in x is y2 is 6.9 minus 3 according to our graph. 6.9 here, then minus 3, then 8 minus 1.8, I think. So let's go back. So we have 8 minus 0.8. So 6.9 minus 3 gives us 3.9 over 7.2 divided by that. Will give us 0.54 as the gradient of our, that's our a. Then our B is the y-intercept. So if you go to the graph where this straight line caught the y-axis, and that should give us 0.6, I think, if you look at it critically. So, and that give us that's 0.6. That give us 2 point something, 2.6 rather. So if you look at that 2.6, then that means this equation become y is equal to 0.5x plus 2.6. So that's the equation of the regression, and this we can use it to predict future uh future what's it called, regression between A and B. So if maybe we also find like a find B when this is find y find B when A is given. So you can also use this to find to predict that. Then having done that, the question says that we have to find the calculate the coefficient of rank. Calculate the coefficient of rank correlation between these two sets score and interpret your answer. So you have to find the correlation between test B and test A using the rank Spearman rank. Then if you have to do that, and that's what you have done in this C here. Draw the table in this format: student test A, test B. Then you have to rank this test A and test B, rank it, give them position. So if you look at test A, this is the rank of test A, this is the rank of test B. Then how to rank test A? The highest number that we carry the first, which is 10 here, we have 1. Then the next one, 9, we carry second position. Then A is then where's the next number? The next number is 7 and 7. So those are the two next number after 9. So both of them have the same value. So we can't give them third and fourth. So that means we add their position together, third and fourth together, divided by 2. That will be 7 divided by 2, 3.5, 3.5. So the next number, which is C, we carry the position number 5, which is this. The number 4 we carry 5 we carry position 6, 4 we carry position 7, 3 we carry position 8, 2 we carry position 9, then 1 we carry position 10. The same thing, rank test B as well. You give us this rank as well. Then you find your D, because to use Spearman rank, you have this formula: 1 minus 6 summation of D square over n square minus 1. So we have 1 minus 6 summation D square over n into n square minus 1. So how do we get our D? Is by subtracting these two rank. Subtract them, that will give us this. Then you square this so as to eliminate the negative. So when you square this, you have this. Then you sum it together, you have 50.5. Then you can return into this formula. We have 1 minus 6 times 50.5 over n is 10 data here, into 10 squared with 100 minus 1. If you simplify the numerator, we have a 1 minus 303 divided by 990, and that should give us 0.69. So we have to interpret it. This is a strong positive correlation between point A and between test A and test B. So there's a strong positive correlation between test B and test A, and that's the interpretation for this. So now the last question is what we are about to solve right now, and that is question number 15, and it's on game theory. It's on game theory. So before we do that, okay, let's just continue. So it's on game theory. We are given that the payoff matrix of the player A and B are shown below. So we have player B having this choice strategy 1 and 2, player B having strategy 1 and 2 as well, and we have 3, 8, 5 and 2 as this matrix. So we have to find the maximum value of the game, the maximum value of the game, and the minimum value of the game. You have to find the mean strategy of the player A and B and the value of the game as well. So it's quite simple as well. Now let's go to the question and see how you can solve it. Now when it comes to game theory, this is the matrix that represent the game, and the first one you have to find the maximum. Maximum means maximum minimum. Find the maximum of the minimum of the game, and find the minimum of the maximum of the game. How do we find maxi mini, or how do we find mini maxi? So in the row, we have two row here, row 1, row 2. We can find the row minimum. For this row now, the minimum value here is 3. And for this row, the minimum value here is 2. So in the row, we find the minimum value. Then in the column, we find the maximum value. For this column here, we have the maximum value to be 5. And the maximum value for this column is 8. So when we know the minimum, you can now find the maximum of the minimum. What is the maximum? The minimum here is 3,2, and the maximum here is 5,8. So we can now find the maximum of the minimum. So maximum will be maximum of the minimum. What's the maximum here? The maximum value is 3, and we can now find the minimum of the maximum. So this is the maximum, which is 5,8. So what is the minimum of the 5,8? That will be 5. So you have gotten the maxi-mini and the mini-maxi. So sometimes in game theory, the mini-maxi and the maxi-mini could be the same value. You can get 3 here or 5 here. And that point is what we call the saddle point. Saddle point is the point where the maxi-mini is equal to mini-maxi. And if the saddle point is, we have the same answer, so it will be easy for us to find the strategy, and we will be able to find the value of the game will be the value we get here, the same value we get here. But since the maxi-mini and the mini-maxi are not the same thing, so that means there's a missed strategy for to get the value of the game. And how do we get the missed strategy? Then the first thing is to do is to find the missed strategy, and is to find the oddment. The oddment. How do we find the oddment for this first row? The oddment for this first row is the absolute value of the second row. The oddment for this first row is the absolute value of this second row. So what do you have? You have 5 minus 2. Then find the absolute value of it. That will give us 3. Right now you should know the meaning of absolute value. That means whatever you get here, 5 minus 3, then find it the modulus of it. Square and find the square root of that number. So that gives us 3. Then the oddment of this second row is this first row. That will be 3 minus 8. Then find the absolute value of it. That should be 5 as well. Then also find the oddment of the column as well. These two columns. How do you find the oddment of this first column? Is by subtracting and finding the absolute values of this second column. 8 minus 2. That gives us 6. Then to get the oddment of this second column, you find the difference of this first column and find the absolute value of it. That will be 3 minus 5 is minus 2. Then absolute values of it is 2. Now that we know that now, then to now get the missed strategy for this this element in this first row, that means you have we have this pardon me for that. To find the missed strategy for this this element here, sorry, this element here 3. So you have this 3 over 3 plus 5. That gives us 3 plus 5. That gives us 3 over 8. I hope you understand that. You are getting the missed strategy for this element we get here. So you have that 3 over 3 plus 5. Then also to get the element for A2, which is for this sorry, to get the element to get the missed strategy for this 3, you have this 3, then over 3 plus 5. Then also forget for the to get the strategy for this 5 for this player B, we have 5 over 3 plus 5 as well, which is this plus this. Then to get the strategy for this as well, we have sorry, this should be 8, not 6. This should be 8 over 8 plus this is 6, not 8. Oh, pardon me, I made a mistake in that. That should be not, this should be 8. This should be 8 over 8 plus 2. 8 over 8 plus 2. Now you're going to have this 8 over 8 plus 2. And that should give us 8 over 10. And that should give us 4 over 5. For this one, please help me correct that. Then for this one now, you have a 2 over 8 plus 2 as well. 2 over 8 plus 2, that'll give us 2 over 10. That'll give us a 1 over 5. So help me correct that. Therefore, the strategy of the player A will be 3 over 8, comma 5 over 8. Then the strategy of player B will be what we get here, which is 4 over 5, comma 1 over 5. So pardon me, change this one. I don't know, that's an oversight from me. Then therefore the value of the game will now be this 3, the 3 divided by this 3 divided by this 5 plus this 5 divided by this 3 multiplied by this 5 plus this 5 multiplied by this 3 again over 3 plus 5. I'll come again. The value of the game will now be 3 multiplied by this 5 plus 5 multiplied by this 3 divided by 3 over 5. This is not the only way I can get the value of the game. I can also do 8 multiplied by 2 plus 2 multiplied by 8 divided by 8 plus 2. I can also do 5 multiplied by 2 plus 2 multiplied by 5 over 5 plus 2 to find the value of the game. You should get the same answer. So like I said, I have 3 multiplied by 5 plus 5 multiplied by 3 divided by 3 plus 5. So that will be 15 plus 15 over 8. That will be 30 over 8. And that will give us a 3 number 6 over 8 as the value of the game. Please pardon me for this. This is an oversight. I don't know how I wrote 6 instead of 8 here. 6 here instead of 8. So it's an oversight from me. So you should correct that based on my explanation. So those are the questions, all the 15 questions for Neco 2022 for that mathematics question that we have just solved now. So if you understand what you have done here, please rate the video, subscribe on it if you have not subscribed on our channel for next video we are going to post very soon, and rate the video and comment on it as well. You can share it as well, and as you do so, may the good Lord bless you. Thank you and God bless.